Hello everyone, welcome to your study guide lesson found on page 87, the real number system. It's lesson 4-7. When we look through the lesson, I noticed that we are looking at classifying numbers and also comparing numbers. So that's actually a good prediction of what we're going to learn. So how to classify real numbers. Now don't forget the real numbers are rational numbers and irrational numbers. So not only are we going to classify them, we're also going to compare the real numbers. Compare them in order them from least to greatest. For our key answer, let's do the quick review. Write the following numbers as fractions in simplest form. We have 4.5, decimal 1/5, and the square root of 25. Okay, they want us to write them all as fractions in simplest form. I'm going to go ahead and turn them, this one into an improper fraction. So it's 2 times 4 plus 1 is 9. Okay, so it's 9 over 2. Okay, this one in simplest form is going to be 15, and it's 15 hundredths, but it's actually going to be, if I simplify it and find that they're both divisible by 5, I know I have 3 5s in the top and I have 25s on the bottom. Okay, and then this one is going to be the square root of 5 is just 5, and as a fraction is 5 over 1. So clearly 5 over 1 is the biggest number. Okay, this is the second biggest number because you have a 4, and this is the smallest number. So what we need to do is write it as so in this order. Okay, boys and girls, so this right here is the key answer. Please circle it. You've learned that rational numbers such as 4.5, 0.15, and square root of 25 are numbers that can be written as fractions. Irrational numbers such as pi and square root 15 are numbers that cannot be written as fractions. These are known as irrational numbers. Okay, you see it here, pi, square root 15. So that you already know we're going to write irrational numbers there. Label the diagram with terms whole, integer, rational, and irrational. Then complete the diagram using the numbers from the number bank. So we have our irrational numbers, and if these are irrational, that means these must be rational numbers. Okay, let's continue to fill this out. We have in here, this is where we have negative numbers, okay? Positive and negative numbers. So for example, this one right here could possibly be just -1, right? What do we call negative numbers? Integers. But integers are also natural numbers, and when we add 0 to natural numbers, we call them whole numbers. Okay, what's another example of a natural number? Remember when you were little and you were learning to count, the first number that you would count would be 1. So 1, 2 are natural numbers. Alright, now let's think of other rational numbers. Okay, other rational numbers that we can have. Remember, rational numbers can be a percent, it can be a fraction, it could be a negative decimal. It can also be a mixed number, for example, like 1 2/3. Okay, 1 2/3. It could be a bar notation, like 2.2 bar notation, and it could just simply be a decimal, like 0.8. Okay, please copy these down as all key answers. I'll be looking that you have the exact same numbers that I do, so that I know that you watched this video. One more that we're missing is another irrational number. I'm going to take the prime number of 7 and put it under a square, and that's an irrational number right there, square root 7. Let's look at the real world connection. Meteorologists use the formula t squared equals d to the cube over 216 to predict the time t in hours a thunderstorm will last when it's d miles across. Okay, so we have d as distance and t is time. So t is what we're looking for. We're looking for the time, okay? And we have to take the distance cubed divided by 216 so that we can figure out how far the thunderstorm is and how much time, okay, it will last. So suppose a thunderstorm is 6 miles across. Okay, 6 miles across. That's a huge thunderstorm, right? Write and solve an equation to determine how long the thunderstorm will last, how long it'll take for it to pass the area we are in. So we use the formula given to us right here, right? T squared equals D cubed over 216. Now, D is distance, and here we're given a distance, 6 miles. So let's replace this variable with 6 miles. And there we have it, okay? We have 6 cubed over 216. What is 6 cubed? 6 times 6 times 6. It's exactly 216. And 216 divided by 216 equals 1. And we know that time is in hours. So this is going to be T squared equals 1 what? 1 hour. So please copy this down as your key answer. Let's try number 2. Okay. Suppose the thunderstorm is 12 miles across. About how long will the thunderstorm last? Round to the nearest whole number. Well, if it's 12 miles and this was 6 miles, doesn't it make sense that it would last double the amount of time? Because it's exactly double the distance? Well, why don't we check that? But maybe it doesn't, because remember, we're working with cube and working with a number that's cubed. So if I replace the number of cube here, actually, you know what, it probably is going to not be double. It makes sense that it would be triple to me, because we are working with a cube number. So I went ahead and just replaced the variable with 12. So I have 12 cubed over 216. What's 12 times 12 times 12? I've got 1,728 over 216 when I multiply 12 into itself 3 times. And now I'm going to divide. And when I do so, I get 8. But wait a minute, is that 8 hours when we have T squared equals 8? I mean, this was 1 because T squared, if it's 1, 1 times 1 is still 1. But for this scenario, we have to see if we can get rid of this square. So now it's going to look more like this. Let me move this over here. It's going to look more like T equals square root of 8. Okay, and what's the square root of 8? Let's do it on the calculator. Okay, I have my calculator here. I go to the function key, it's square root of 8. And it is 2.82, okay? 2.82, and we have to round to the nearest whole number, right? So T equals 2.82 or 3, right? We round to the nearest whole number, 3 hours. So yes, my prediction was pretty close, almost triple. You see that? Alright, and finally let's do some comparisons, okay? Identify and compare numbers. Circle the correct phrase to complete each sentence. Explain your reasoning. Okay, 0.67 bar notation is less than or greater than 60.7. Well, let's see. This looks like it's a terminating decimal, which means there's a 0 coming after it, right? But we don't write the 0. While this is 7 infinitely. So, this 7 bar notation makes it greater than this terminating decimal. So 0.67 bar notation is greater than 0.67. And what better way to explain it than by using math? You see, you can just simply write it as so. We write the next 7, and remember that dot 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 means it's continuing. Okay, it's greater than, and I wrote a 0 so that you can see that it's a terminating decimal. Square root 33, is it less than or greater than 6? Well, when I punch square root 33 into my calculator, I get 5.74. So this would be 5.74 is less than 6. There you go. 2.5 compared to square root of 8. Square root of 8, I know when I punch it into my calculator, I get 2.82. We already worked with that today. So we know that 2.8 is greater than 2.5. And finally, cube root 100 and 400. Well, we know that 400 is 4 whole numbers, right? It's just 4. 400 is 4 whole number. But cube root 100, when I do the cube root 100, I get 4.6. And I know that 4.6 is greater than 4. Okay, please copy all these answers down as key answers. And finally, we have solve equations. Complete the organizer to solve the equation x squared equals 10. Step 1 is simple. Write the equation. Step 2, definition of square root. What do we mean by the square root? Well, when we remove the square root from this side, x squared, when we remove the square, the exponent, we know that on this side it becomes a square root, and it can be plus or it can be minus. 10 times 10, okay, or I'm sorry, both numbers that multiply to give you the square root of 10 can be both positive or can be both negatives. And the third step, use the calculator. When I use the calculator and I punch in square root 10, I get 3.16. Or we can round up to the nearest 10, which would equal x equals 3.2, which is the positive answer. Or we can have the negative version of negative 3.2. And there you have it. And finally, boys and girls, write 2 to 3 sentences to summarize the lesson. What did you learn today? What did you learn? You learned to compare, to identify square roots. You circle, you correct the complete sentences by comparing different real numbers, okay? And you solved the equation by following steps. I'm just looking through the book right now to see what you did. You listed and organized and used vocabulary. Any of those would be fine. So how to classify real numbers and how to compare real numbers. Okay, boys and girls, I'll see you in class.